Okay. Continuing on with the quantitative data. Last time we looked at frequency table for the quantitative data, right? We did classes, class width, and we also looked at histograms. Today's the stem and leaf plot. What we do is we split the numbers into two parts. One is called stem, one is called a leaf. The stem can be any number of digits. However, the leaf is only a single digit. We usually take the leaf to be the smallest place value. If you want to compare data sets, you can create a back-to-back stem and leaf. For stem and leaf, you typically have the stem on the left, a vertical line, and then your leaves on the right. With a back-to-back, your stem is just going to be in the middle, with a vertical line on the other side. And then you have leaves for one data set on the left, leaves for the second on the right. This will probably be a very short day because it's just stem and leaf plots today. So here we have scores of a test. And we'll just create a stem and leaf plot by hand. This one's better. Like with the frequency table, where we didn't want to create classes that were empty, you also don't want to have stems that have no leaves. Right? So clearly we're going to set the stem to be the 10th digit. We don't want stems 0 through 4, because there's no values between 0 and 50, right? So our stems are going to start at 5 and go to, we don't need 10. Let's just look at all of the 50s. Also, as a general thumb, we tend to keep the leaves in ascending order. Thankfully, this is already listed in ascending order for us. 52, 58, or not 52, sorry, 56, 58. Again, try and leave enough space. I don't want to read that as 68. So you want to leave yourself enough space so that you know it's a 6 enemy. But even that would be fine. About 61, 62, 62, 63, 64, 66, 67, 68, 69 gig. That's what? 1, 2, 2, 3, 4, 6, 7, 8, 9. $70, $72, $73, $74, $75, $77, $78, $79. Look at the ones digits. 0, 2, 3, 4, 5, 7, 8, 9. Right now, misaligned. $82, $84, $85, $88. And that's just what, 91? Those lines. There's the stem and leaf representation. What we can also do, if the leaves start to get too long, we can break the leaves down into multiple stems. Same data, but use 2 lines per stem. Each stem, if we're looking at the units digit, has how many possible leaves? What are the possible values? what are the values you can put in the unit digit? If you write out a number. What would go in that missing blank? I have the hundreds, the tens, and the units. This is kindergarten.
3.
Hmm?
1, 2, 3.
Is that the only possible number?
No.
What are all the numbers? That's what I'm asking. What digit can go into that unit? Not any number. There are specific values. I can't put an 11 in there. That wouldn't make sense. To list out all the numbers where 1 is in the hundreds and 2 is in the tens. 0 through 9, right? How many are that?
10.
So probably the best way to split up your stems is directly in half. 0 through 4, 5 through 9. I'm gonna have enough. So the first stem would be 0 through 4, the second stem 5 through 9. And I don't have to go back and look at the data because we already have the stem in leaf 5. And so 6, 8, no, sorry. 6, 8. 1, 2, 2, 3, 4. 6, 7, 8, 9. Zero, 2, 3, 4. 5, 7, 8, 9. 2, 4. 5, 8. And 1 and nothing. That would be if you want to split it. Into multiple stems. Daily water intake, measured in liters for 30 randomly selected individuals given. Right, stem and leaf plot for this. What digit are we going to use for the leaves?
Numbers in the 10.
The 10th digit, right?
Yeah.
Which means everything else will be the stem. How many stems do we have? What are they?
1, 2, 3, 4.
Once again, that is an ascending order for us, which is nice. Now go down each stem. 1, list out the leaves.
2, 5, 8.
Two, list out the leaves.
1, 2, 3, 3, 4, 5, 7, 8.
What were they?
1, 2, 3, 3, 4, 5, 7, 8.
This one.
Zero.
0.
Oh, 0.
Three is next. List out the leaves.
0, 1, 1, 2, 3, 4, 5, 7, 7, 8.
And now you're down to the fours. List out the leaves.
0, 1, 2, 3, 4, 5, 6, 8.
Kind of look at this. What's the mode? How many modes are there?
Three.
I see 3. What are they?
3, 7, and 1.
It's not just 3, 7, 1.
Or 1, 1, 3, 3, 7, 7.
So you're just looking at the leaves, not the entire data point. Right, so I agree, the leaves 3, 1, and 7. But on which stems?
2.
So what does a stem of 2 and a leaf of 3 mean?
Would it be
What is it?
2.3. 3.7. 3.1.
Right?
Yeah, I get that.
What's the shape? What is it? That's not incorrect. It's a very slight left skew. I would approximate this as symmetric. Approximately symmetric. I would take either. If you say it's a slight left skew, that is correct. You could also say it's approximately symmetric. So there is a major problem with the stem and leaf. Let's just say that's all you're given. With no other information. What does a leaf of 7 on the stem of 7 mean?
There's a repeating number.
77.7.
But it's 77 or 7.7 most likely. Which one? No idea. Without context. That is an issue. Which is why generally you have to include, if you're given just a stem and leaf plot, or you're showing just a stem and leaf plot in a presentation, what the stem and leaf plot is representing. In this case, test scores. So run times in minutes for several movies along with their ratings. G and PG and rated R. Create a back-to-back stem and leaf plot. Now, we know we're doing back-to-back, so the leaves, or the stem rather, is going to be down the middle. So first decide what digit do the leaves represent. What is it? Tens?
Hundreds of tens.
I'm talking about the leaves, not the stem.
Oh, leaves, all right, the units.
Yeah, it's going to be the unit digit, which means everything else is the stem. You have to look at both data sets. What are the stems? List them.
8, 9, 10, 11, 12, 13, 17.
Generally speaking, you don't want to skip stems.
So then just 8 through 17.
So you should also include the 14, 15, and 16. I think it actually really depends on the source. it is not going to matter which data set goes on which side, as long as you list which data set is which. Just so I don't confuse myself, I'm going to stick with what I have in my notes and go G and PG on the left and R on the right. I might do something like this. G, PG. Just do one at a time. So start with the G and PG rating. '89. This is where it gets a little difficult. I'm going to put it this way. I'm going to write right to left for the left leaves. And then I'll write the normal way left to right for the right side. '90s, list out the leaves.
8430.
Now we're on the 10s.
3, 3, 4, 5, 8.
11s.
7, 8.
12s.
9, 9.
13s. 'Are there any 14s?
No.
15s?
No.
16s? 17s? You're done. Now look at the R's. 8,
No.
9,
Yes.
list them.
6.
10,
2, 5, 6, 6, 3, 11.
11,
3, 4, 9.
12, 13, 14, 15, 16, 17. Where's the stuff? Get back to that. So I could use this to ask the question, on average, which rating has longer run times? Looks like the R. I would also argue that it's not really enough of a collection to conclusively say that. I probably want a larger sample of each. And then this is where numbers don't lie, statistics don't lie. How you represent them, however. I could purposely select shorter runtime movies for G and PG and longer runtime movies for R to support my claim that R movies run longer. And the data would support it, even if it's not true. Getting to that point, which brings up a good point. Whenever you look at a study, you're looking at the conclusion of the study, you're looking at the data, look up who funded it. There was a study that shows that electric vehicles are more efficient than gas vehicles. It was funded by Tesla. Should you really trust that result?
It's biased.
Yeah, it's totally biased. That supports Tesla, right? So you should kind of question that study and the results. It doesn't mean the results are wrong, but question it. Also look up how was it collected. Now, if the results were it's better to get a gas vehicle and was funded by Tesla, probably believe that because it doesn't help Tesla at all. It's actually quite detrimental to them. What are we told here? Stem and leaf plot is given reconstructed data. Fortunately, with Excel, it's kind of difficult to get it to actually look like a stem and leaf plot. Excel PowerPoint. If I wrote these in lots, I could definitely get the projects out. Let's see. We're broadly going to have two possibilities. The stem could be tens. The leaves would be units, right? And then the stems would be everything else. Or it's possible that the leaves are the tenths place. We don't know. I'm going to work under the assumption that these are whole numbers. What are the data points? And list them in ascending order. Yeah, that'd be your data set, right? data, import it. Why is it not showing? So there's our run times in minutes. So we want to create a stem and leaf. Well, if you scroll down, look, they're not even ordered for us. Isn't that? And there's 150 of them, so again, if you want to do this by hand, go ahead. It would make sense looking at these, right, that our leaves are going to be units. Which would make the stems everything else. Now there's a reason why you need to know that. Because unfortunately, there is no direct option in Excel just to create a stem and leaf plot. So we're going to have to finagle it a little bit. I actually don't want this yet. So let's go. What I'm going to do is I'm going to go equals int is going to round the entry down to the nearest integer. Since we're saving the units digit for the leaves, just divide each value by 10 and take that integer. Scroll down to do everything. To determine the leaves, it'll be mod, which is a remainder. After a number is divided. So we want the remainder of the digit. Why is it doing everything? No. So A2, when it's divided by 10. That will give you the units. Bless you. What is going on now? Now I can start to create my stem and my leaves. We only want unique stems, right? I don't want to list 8 out, how many times you have an 80. So this is unique. It'll be C2 to C50, 151. Right, where I list out all of my integers when divided by 10. This is gonna be fun. Text join. Space. Tell it that space. I definitely want true. Sort. Filter. Two. D151. C2. C151. Equals. I think that's all of my parentheses now. I'm actually surprised I didn't get a hiccup. Technology actually worked the way I wanted it to for once. There's my send. Right, to get it to be the proper size, I just double clicked. If you look. Right, scroll up to H because that's the column I'm working in. Notice how it changed to that kind of like double arrow thing. Double click it, it'll automatically size it for you. And now before anything crashes and undoes all that. Okay, so I apparently mislabeled the one from yesterday. That should have been F, not G. Oh, well. I'll fix that later. Actually, I can just open and fix it now. Let's do that. There, fixed. Now what you can do is, I obviously don't expect you to memorize that formula. This Excel file is available for you on SharePoint. If you just click in the cell, notice up top it gives you what I used. It gives you the formula that I used. So you don't have to memorize it. Split. If you wanted to split into two stems, you can, but that's going to require you to use an if command, which is now getting into coding concepts, so I'm just not going to do that. Oh, it's good. STEM plus. Very simple way of organizing the data. Also quite tedious. Any question?
Now, for the lead part, instead of just spacing them out, we put commas too, or is that like make it?
No, you do not separate the leaves with commas. So you can space them out, you can, while I don't see it too often, you can not have a space and just list them out. But you definitely want to separate them with any kind of limiter. And you also, if you notice, I was trying to be, particularly when I did these, we want to try and keep everything lined up. Right, so notice I tried to keep all in a line so that is more visually accurate, shows you, okay, what has more in it, kind of helps you with the shape. So also try and keep that in mind when you're doing anything. Doing it with technology, right? Excel didn't matter, it does it automatically for you. Why are you not? Right, Excel does it automatically for you because it's technology, it does it nicely. So when we're doing it by hand, just make sure to try and keep them lined up. Yeah. There's one last thing to cover with descriptive statistics. Which means one last thing to cover for the Unit 1 test. And that's misleading graphs, which is even shorter than this. That's probably not going to take me maybe half an hour. So I would say on Tuesday, maybe bring your laptops or something. For the extra time, work on the group project. So you have some class time to do it. You can also do it today if you want, because I'm going to hand out the worksheets, but the rest of the class will just be for the group work. So if you'd rather do the group project, that's perfectly fine as well. All right, so get into your groups, I hand out the worksheets, then the time is yours.